There we go. So, our assignment 1 grades have been posted. I think I posted them, right? Did I? Yeah, okay, good. Barely? Well, I'm hoping people were pretty happy with how they did on that one. Let me just make sure. Published. Yeah, everything's published. Good, good, good. So basically, in general, I was quite pleased with the assignments. You guys were meeting most of the requirements in most cases, which means you got most of the marks. Yay! So yeah, good work everyone. Solid effort. I hope everybody enjoyed it because it was, probably one of the more fun assignments that you have. Putting together a web page can be fun. But anyway. Lovely assortment of horrible, debilitating medical conditions. So, let me just see here. When did I make assignment 2 due?
March 3rd. Seems a bit far away.
It does, doesn't it? March 3rd. I have the right month?
I don't know, Dr. Moore, but you seem to give us like a 3-week bonus.
Mind if I pull that in? I think I have to.
When's the next assignment? Assignment 3 due? Like what is that?
Well, I should be introducing it today, actually. Or let me think here. What? Let me take a look here. So assignment 1, that was due February 4th. Okay. That was 1 week ago. So the assignments should be every 2 weeks, but next week is reading week. So it should be the 25th, because I'm giving you reading week to work on it. Right? So I don't think I gave you 3 extra weeks. I think I gave you 1 extra week. So if you don't mind, I think we'll just tighten that up a little bit so as to be able to get through all of the content. Oh, there we go. Done. And now be concerned with assignment 3. So, this assignment requires the PHP stuff we did last week and the AJAX stuff we're doing this week. It's my habit to introduce the assignment after we have covered the week, like the first class after we've covered the relevant material. So, assignment 3, I will introduce it to you as soon as we're back from break. This week we will do AJAX, and then you will have 2 weeks to complete this assignment. Does that make sense? So far, so good? Good. So, yeah, wonderful. So, why don't we just pencil in our due dates here. So that will mean that it will be due March 10th. 4. Could we do March 24th? Yes, April 7th in that case. Let's take a look here. Let's see when is class actually ending?
We're running out of time. Are you teaching in the summer, Dr. Moore?
No, I'm going on pat leave in summer.
You're going where?
Oh, I'm going on paternity leave.
Oh, that's right, okay.
And I don't think, are you guys taking classes in the summer?
Not unless we take some.
Ordinarily, I do teach in the summer, so. We have like a winter intake that for 559, they take in like a whole incoming class in January, do their first semester in winter and then their second semester in the summer, so they're synced back up with everybody for the fall for third semester. So yeah, it runs right around the year.
Do they weed out enough students in that period to cohort them in the second year?
Oh yeah, man. Like 2 of the
I'm
primary.
surprised they're actually able to do that, like accept a whole group
And
in
just
January and then.
weed them out, yeah. Certain courses like certain very important courses like Java, object-oriented programming have a 50% failure rate. JavaScript, I believe, is a 50% failure rate as well. But an interesting thing about the program is it doesn't have any entrance requirements.
We need re-entrance.
It doesn't have any entrance requirements.
Oh, okay.
So you don't need a particular average coming out of high school or anything, or have taken any particular courses. So a lot of people end up trying their hand at it without having had a reasonable chance of success even from the very beginning, if you ask me, if you want my honest opinion. But,
It's a moneymaker.
well, you know, we live in a society where if you want to try it, you should be able to try it, I guess. You know, that's a value in our society. Anyway, what was I looking at? When's exams?
When we're done.
Yeah, let's see here. So final exams start April 13th. So I think right now we've got 1 week squeezed, don't we? So, yeah. So, I think that this schedule, I really hate making tests due like during exams, or making assignments due during exam week. Have you guys started on assignment 2?
I'm almost done.
You're almost done? Is it reasonable to move that deadline up another week? So we can,
It's for me, I can't speak for the rest of the class.
no, you don't, you need to keep it where it is.
I know that Cyrus going away to the Middle East over the reading week, so I don't know if she's going to be able to be doing the work. Yeah.
Well,
Like, that seems like a lot not to work. It's sick.
yeah.
What is that?
Yeah,
it's
no,
an optional, okay.
Oh, yeah, no, these are,
The same, assignment 6, there's 16 optional.
Yeah, there, for the last two assignments, there's like, alternative option if a strong class. Normally when this type of thing exists, I open up both of them, and if you want to attempt the harder of the two, I'll throw a couple of bonus marks at you if you do well on it, but you're not in any way obligated to attempt the harder version.
Well, then we're okay then. Equal
Yeah.
7, that's fine. I
Um,
don't know what the Laravel, but.
Yeah, like, this is like, how about this? We will provisionally give 1 week for the final assignment. I think that it's probably been reduced in scope and difficulty quite substantially, so that might be reasonable. And if you guys are having an extremely difficult time with it, I will think about moving that due date out a little bit, although I know that pushes it into your exam period, and I know that's not desirable. But I think when this course was designed, it was not designed with the break week in mind. Either that, or I'm giving you the assignments too late, and you're meant to be working on them while the material is still being taught. So, how's that? How about we make the due date for assignment 6 April 14th. Which is the Sunday before exams start. And then, if more time is required on that, we'll go for that. Does that sound like a reasonable plan?
I think that's reasonable.
Yeah, okay. If that sounds achievable, then why don't we go with that? Sounds good. So we know when all of our assignments are. I've also, during this process, released them all, so if you want to take a look at what you're in for, that's going to be right there. Assignment 5 was April 7th. Assignment 6. I'm going to have to manually manipulate the spreadsheet over these options, aren't I? Oh well. So it goes. So I just had like a quick look, like alternative option for a strong path, for a strong class. I don't think this is stuff like salting and hashing passwords and that sort of thing is not something I expect we will get to in this class. So also, this would have been a lot to expect of my PHP class to put that in an assignment. So only if you have time on your hands to do some extra research, I'd say. Don't worry about it. It's not my expectation that you guys will do the extended ones, but I think it's still useful to see them. So, all right. Any questions? Okay. Comments? So let's talk about Ajax. Oh, we're also doing PHP input validation. Okay. Let's do it. So, I'm happy I introduced these topics to you last week. We will talk a little bit more, in more depth, about how it is that PHP correctly takes inputs from things. You might be saying, oh my goodness, this was supposed to be Ajax, why are we talking about PHP again? But, basically, what we are talking about, what the broad theme of this week is the communication layer, right? When we talk about Ajax, we will be talking about the manner in which the client sends information to the server. First, it's useful to see how the server receives information from the client, and how you set that up so that you don't make your website eminently hackable. Does that make sense? So, again, I don't like to give people half of the information, so we've been talking about the proper way of doing this so far. This will reinforce those concepts. We'll go over it again in a bit more detail. So, HTTP requests. So, hopefully everybody remembers from last week the way that a PHP script receives information from an incoming request packet. The server itself receives the packet, parses the information out of it, and stores that information into what are called superglobal arrays in PHP. The superglobal arrays are associative arrays, meaning they behave like JavaScript objects. These are not arrays in the numeric sense. When we access something from GET, the index that we provide is a string rather than a number, right? This makes it similar to something like, if I were to take that and sort of translate it into JavaScript-esque syntax, it would look something like get.x, right? It's just a different way of saying the same thing. Make sense? So, the values which are stored in the superglobal arrays are just the raw data which has been sent from the client. Whatever the client sent, that's what's in the superglobal array. The server does not do any checking of it whatsoever. That is your responsibility. The reason the server doesn't do any checking of it whatsoever, the server has no idea what context this data is being received in. You, as the developer of the web application, do know what context the data is being received in. Sometimes things that look like a hack, or things that might, from one perspective look like they're enabling hacking, maybe that's desired functionality in your particular instance. The server doesn't know what you're doing with the data, and it remains agnostic. So, that is why validating the data that's being received is our responsibility as the authors of the PHP code. Does that make sense so far? So, we often need to check to see if the values that we've received are valid. That is to say, are we receiving data that is the correct data type? Are we receiving data that's in the correct range? Remember our factorial example from last week. Are we receiving data that will cause problems if it's used without being checked for special characters or something like that? Hackers can enter a script element into forms, form inputs, in an attempt to run malicious code. We had an example of that last time in class, but I'm happy to do it for you again. Basically, PHP is a text processor, right? When it's sending information out to the client, the default form of that information is as HTML, right? It's just sending a string, but the client will interpret it as HTML if it's been configured to do so. Now, if it's HTML code, and you're doing something, silly, like bouncing information that's sent by the client directly back into the client, if the person who creates the request embeds HTML code inside of their request, and that information is reflected back into the client, it gets run as HTML. Any HTML tags that are included are executed as HTML. If I include a heading tag, I get a new heading. If I include a new link tag, I get a new link. And if I add a new script tag, I get a new script. Now the problem with adding a script tag, of course, is that these little guys can load JavaScript from anywhere on the internet, including bad, dark, evil places where people have put bad, dark, evil pieces of JavaScript. JavaScript can be used to collect a lot of information about your computer, what you're doing in your browser, all kinds of fun stuff like that. Have you guys ever heard of a keystroke logger? So, a keystroke logger is a little program that all it does is pay attention to the keys that are pressed on your keyboard. It makes a log of them, and it sends that information back to, whatever other server where this information is being collected. Now, if your computer has a keystroke logger installed on it, if you enter a bank password, right? If you enter your banking information, like one way of trying to get at that information is to try to crack the outgoing data packet. This is difficult as it's encrypted. But an alternative way of getting the same information is to just pay attention to the activity on a user's keyboard as they're entering their credentials. Right? So, so JavaScript can do this. At least, it can't do it for the whole operating system. That's like a virus proper, right? But it can do it on a page where the keystroke logger has been loaded. And if that happens to be your bank, that is one way that a hacker could obtain your login credentials and therefore access all of your sensitive personal information. Does that make sense? So basically, you don't want any strange JavaScript being executed on your browser there. It's just not a good idea. there are active countermeasures that you can take. Sometimes there are browser extensions you can get that just block JavaScript. They block JavaScript that isn't written, like basically you have to go in and whitelist the scripts that you allow for X page, Y page, etc. It takes time to set up the list of allowed JavaScript scripts, but once done, your browser is incapable of running JavaScript without you being, giving it explicit permission, which in theory protects you against that sort of thing. The only problem is the end user's awareness of the JavaScript that you're presented with. If something like Facebook is trying to load 20 different JavaScript scripts, which ones will break the site and which ones will not if you disable them is like basically trial and error, and it's an intensive process. I speak from personal experience. So, validating input manually can be a lot of code. For example, if we want to validate that a parameter A is present and that it's a string, we might do the following. So, number one, we have an if-else statement. Our first condition, if, what's that exclamation mark do? Yep, Boolean negation. If not is set, get A. So isSet is a very important function in PHP. It basically tells you, if I have the associative array get, is A an entry in it? Right? So you can kind of think of an associative array as, something like that, right? What isSet will do, is set C, looks it up, it exists in there, so that returns true, right? Is set Q, traces through the array, Q is not one of the keys, so yields false, right? So, once you know whether that entry is present or not, it's now up to you to handle things how you wish, right? In this case, we have a PHP variable A, which is being created in all three of these branches. Sometimes, not having received an expected parameter is sufficient reason to just kill the script, right? You want to send an error code to the client and just kill the script. That's one option, right? If you want to kill a script, exit 0. 0 is an exit status, meaning everything went as planned. Non-zero exit statuses usually indicate an error. It's not necessarily an error on the part of the PHP script to reject bad input, right? It's an error in the client, not in the server. Does that make sense? So, whether you want to set A to null in this case, or whether you want to exit the PHP script, these are all options, right? It's programming code. You can basically do anything you want. Fine. So that's our test to see if the incoming data packet had that parameter in it. Remember that the contents of the get superglobal is all of the incoming get parameters. They've been parsed out of the packet, right? So, if A is not set in get, that means that the client didn't send a value for A, right? Perhaps that was expected, perhaps it wasn't. It's up to the PHP script to decide how it wants to handle incomplete information being sent. Does that make sense so far? Good. So, let's discuss the next one, isString. This one's a little bit more straightforward. isString simply returns whether or not the value given is a string, is a typed string, right? Now, it just so happens that this is a little bit of a technical error here, actually. When you receive information from the client, it's always string until you parse it as something else. Right? Even if it's numeric, you still get that as a string. So, this will actually, this will never fail. You will never actually hit this case, right? Because every value inside of the superglobal is a string. isString here will always turn out true. We negate it as false, so this is a false branch and is therefore not executed, ever in any case. But, if this were an integer input, it might be a little bit more useful, right? What you're primarily interested in, like, is my data numeric? Is it a string? Like, you know. You can test data types too, is the point. There's a large number of these things in the PHP documentation. So, for example, isInt tests to see if the variable is a number or a numeric string, right? So, if this were isInt, it would work for values like 7 and 73 as a string, right? Oh, I'm sorry. Sorry. No, this is just for ints. isNumeric is the one I'm thinking of. There you go. So numeric determines if the given variable is a number or a numeric string. Pardon me, isInt is still just for integers. This is why it's important to read the documentation, right? And to read the documentation carefully. So, there is, as you can see, a whole bunch of these things for all kinds of different situations. However, the point that we're kind of making is that this starts to get quite complicated. For one thing, we are having to check a lot of different cases using an if statement. And number two, there's a lot of important checking that we're not doing, right? If we're expecting A to be a string, we should be checking for and sanitizing out script tags. This is not doing that, right? You can imagine that checking for and sanitizing out script tags, that's a bit of an operation. You don't want to write that every time, right? That is why we have the filter input function. It performs all of the checks on the previous page, plus a bunch more things, and it just does it in one line, nice and simple and easy. It's a bit of a long line, we will admit, but that's just because PHP can be a bit verbose sometimes about some of its tag names. So, filter input requires 3 arguments. Number 1, type. Where is the input coming from? Right? A very important piece of information, which is, we didn't talk about, but one of the important pieces of information encoded here is where we are expecting to find our input parameter. Here, we are expecting it to be in the get superglobal. Depending on the request packet type, different superglobals are used to extract, different superglobals are used to hold the sent parameters, right? If it's a GET request, the server places the parameters in the GET superglobal. If they are a POST request, they're in the POST superglobal. If they're delete, they're in delete. If they're input, they're input, etc., 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 etc. So basically, you have to know what your request type is. Type is your request type, right? So in our case, we're probably going to use input POST or input GET for most of it. Does that make sense? So in computing and computer programming, we have like this semantic problem where we put too many meanings on words sometimes. Type is like the word is really overloaded in terms of definitions. Here, this is not meaning data type in the same way that a variable is a Boolean, right? This is meaning input type of the incoming request packet. So just be aware of that. Number 2, we provide the name of the parameter. If you're looking for a parameter, you should know what the name is, and this is where you put it. And number 3, a flag, which indicates what type of validation we are to perform here. Am I recording? I am. Okay, I am recording. It's just the LCD on the camera is like flashing, and I'm not sure why. Yeah, maybe it's like switching between dimness levels or something. I don't know. Yeah, I'm sure. As long as it doesn't come out in the video, that'll be fine. And if it does, it's kind of like, so it goes. So, there are many flags for performing validation and sanitization of the input. This is just a very small selection. Filter validate int, filter validate string, validate email, sanitize string. The purpose of each of these is to, basically you want to validate different things depending on the context, right? Perhaps the form element that you're extracting information from, that particular text box was, please put your email here, right? If an end user puts nonsense garbage into the email box, a non-valid email address, what happens if you try to send an email to it? Yeah, like, well, actually what will happen is, if you send an email to well, I think, like, everybody who uses email should have seen this already, but basically what happens, there's a sub-process inside of mail servers called a mailer daemon. It's spelled daemon. But it's pronounced demon. It's like a little thing with horns and a pitchfork that's just putting emails in slots. That's what it is. But basically, your mailer daemon is responsible for routing email to, from one mail server to another, and also giving it to the address indicated. So basically what happens if the, so the way that email kind of works, right? You've got two classes of errors that can happen, right? The first is an unrecognized domain, right? This is like the server that you're trying to send the email to, right? So if I misspell mohawkcollege.ca and I give it like one L instead of two, right? The mailer daemon will not be able to find the other server that it's sending this mail to. So it will return one type of error at that point, right? Secondary check. This email server has a list of email addresses which it supports, obviously. This has to be one of them, right? This has to be like a designated mailbox. If it's not, then a slightly more complicated form of rejection occurs, where the mailer daemon, your mailer daemon, sends the email to the other server, but the other server responds back, that email address doesn't exist on my server, I'm sorry. I can't deliver it because this isn't a valid email address. For both of these, you get an email back. Basically, the way that the mailer daemon responds to you is by sending you, and I'm sure everybody's gotten one of these at some point, an email that says, your email was undeliverable, and then it provides like a whole bunch of what looks like garbage, right? Well, it's not garbage to a mailer daemon, right? And it's also not garbage to a systems administrator, right? That's all information about how and why and in what form it was undeliverable. But basically, those are the consequences if you try to send email to an address that doesn't exist, right? So if you're taking emails by form, it's highly, highly probable that it's highly probable that a client is going to make a mistake at some point in time, right? The first step in protecting against this is, of course, validation in JavaScript, right? Validating on the front end so that the user can see, right? How this actually works is, sometimes the text box will be like highlighted in red and it will say, this is not a valid email address, right? Sometimes this happens as you're typing it, sometimes only when you click submit. This is because in JavaScript, sometimes they're running the checking as events on the individual form elements, which is, let's be honest, kind of nice and the nicer way of going about it. The other way, which is like the cheaper option, because it's easier to program, just run all of your validation checks before actually sending the request when the user hits validate, right? So basically, if you're setting up an account for something and someone's entered a bogus email address and you send email to that bogus email address, number one, it still looks to the client like everything's working, right? The client is not necessarily aware that in the back end the server's getting emails bounced back off of the mailer daemon. Number two, whatever email address the server has configured, which is sending these account validation emails or whatever, like no reply at mohawkcollege.ca, an address of that type, which is just a robot address, right? That thing's getting filled up with undeliverable email responses from the mailer daemon, right? So, not only is that like just kind of junk on the server, right? There has to be a process whereby, your processes on your server are waiting for the bad, mailer request, and it's like, oh, I just got the email, the undeliverable email, and now I'm going to send that information somehow back to a client, even though servers cannot initiate communication with clients, only clients with servers. So it's like, far and away, the earlier you catch a problem like a bad email address, the happier you are. The best place to catch it is in JavaScript on the client, but as we know, what do we never do? Can't trust the client, absolutely. The client can always find some way around your validation checks in JavaScript. If by no other means than to formulating and sending a packet request themselves manually, which you can do. Absolutely, you can do. There are lots and lots of pieces of software packages and programs that let you test websites by firing composed packets at them. So, that's why you might need to validate your email in PHP. You must do it before you actually try to use it, right? And you cannot rely that the client has been able to filter it. So yeah. Full list available in the final resources slide. Final resources. Full list of filters. Here we go. So, validate filters. Lots and lots of them. Sanitizing filters. There you go. Other filters. Filter callback. Sure. Filter flags. Which are internal, don't worry about them. Mostly, just worry about sanitize and validate. Basically, just write down which filters you use for which data type, and that should be sufficient. There we go. So now that we've talked about the necessity of using filter input, let's talk about the different results that filter input can return. And unfortunately, as we stated last week, this is a situation where it actually becomes important to be able to use the triple equals equality comparison as opposed to the double equals. My fourth student is quite late today. Oh, is she? Okay. Well, good thing I'm recording then. Yeah, okay. Hope you're feeling better by the time I publish this, which, let's be honest, at the rate I publish things, you probably will be feeling better by the time I publish this. You know what I did? It's my fault. I bought a larger memory card, and now I can put like a whole week's class on one memory card, so like just my inherent level of laziness means that I'm publishing my videos weekly now, so, you know, there you go. That's how improved technology it leads to decreased quality service. So filter input returns one of three things. In the case where everything is successful, the thing you're validating is actually the thing you're validating it as, and it's, you know, actually there present in the packet, you get the value. The value is the return result of filter input, which means, in most cases, the way you will use filter input you will assign the return result of filter input to a variable, and then you will use further checking. Make sense? So, filter input will return null in the case where the parameter you're trying to find wasn't there. So, if is set would return false, filter input will return null. Make sense? So, the next situation we have is if the validation fails. Now, validation and sanitization are two different operations in this context, right? If we are validating, we are checking to see if the received input matches the input that we are expecting, right? If we are validating for an integer, we are expecting the string to be an integer, right? If it's not, right, if is numeric, in the case of numeric inputs, would return false. Then, filter input will return false as well. If it's not one of these cases, you get the value itself. But if it's one of those two cases, you get either null or false. Now, here's an issue, right? And we talked about this last time in class, but false double equals null is true in PHP, right? False double equals 0 is true in PHP. Remember that the two equal signs is weak equality. It's value but not type equality. Now, you might make an argument and say, I don't know who's considering 0 to be the same thing as false. I don't know why that would be the case, that would be equivalent. Turns out there actually are reasons for that. But if you were to write an if statement using double equals, basically, the problem you run into very quickly is that those two if cases cannot be distinguished from each other. So, for example, if x equals null, if x equals false, or else if, and then else, something like that, right? Presuming, so let's go through it. Let's trace this little bit of code, assuming. Oh, I'm sorry. That's a little far away for you, isn't it? Are you okay? I'll try to do it more centrally. Sorry. So, if x is null, does this condition come out true? If x is null? Let's assume that this filter input operation returned null as a result. If we then compare x to null, do we get true or false? We get true, because null is equal to null. Sure. So this branch is executed. That is expected behavior. That's all good. What if x is equal to false? Because this is an if statement, we evaluate these in the order they appear. Right? So, if x is equal to false, is false equal to null? It is. This comes out true. This branch is executed. This branch is not executed. We therefore have a bug. Right? We wrote a whole branch here specifically to handle the case where x is false. It's never being executed. Do you understand where the error is coming from now? I'll do an example in code to support this, but that's the problem, right? If x is equal to false, this condition will come out true, which means we will execute this branch and not that branch, because this is if else, right? So, this guy gets executed, even though that's the wrong branch for this particular type of error, right? It could be as simple as sending two different error messages back to the client, right? In the first case, parameter was not sent. In the second case, parameter was not an integer, or whatever, right? But under these conditions, if x is false, the information received by the client will be that it wasn't sent when it was, right? If we send the value and it's invalid, filter becomes false, we hit this tells it to reply, parameter is missing, but the parameter is not missing, right? The parameter was invalid. It's a different error condition, right? So, what we end up doing is sending bad information back to the client, which, in general, something you should avoid. So, fortunately, the fix for this is very simple. You just introduce the triple equals checking both value and type. So, false triple equals null yields false. So that's what happens if you're performing a validation filter. Let us now consider sanitization filters. So sanitization filters come in two primary varieties. The first variety is a replacement filter. We are taking some problematic characters and replacing them for other characters which are not harmful. The other type of sanitization filter is a removal of the offending material, right? So, sanitized string is a removal filter. If you send the script tag into filter sanitized string, it will give you the output back again without the script tag. It will remove the content, the script tag itself and the contents. It'll just pull it out. So, that leaves us with a slightly interesting failure condition. What if the entire string is bad, right? What if the entirety of the incoming string is just one big attempt at a cross-site scripting attack or something? The equivalent of validate returning false is a sanitized filter returning an empty string, right? Empty string, nothing in it. Now, it's very, very important to understand that an empty string is not the same thing as a null, right? But, let me just check this. PHP. So, W3 Schools has an online PHP interpreter which you can just run, if you want to, I don't recommend doing your assignments in this, but if you just want to get something quick running, this will do you. Echo empty string, obviously returns nothing. Here's a question. What about echoing null? So, null, when converted to a string, becomes the empty string. So, null becomes empty string under conversion, type conversion. Automatic type conversion, right? So, 1 means true. So, despite the fact that we're not like, so there's actually a fairly large category of things that will equate to, 0 or false. Basically, in the group of things that will all equate to each other under double, you have null, 0, false, and the empty string, which will all equate as each other under double equals. But under triple equals, you get nothing. Let me expand this into an if statement. False. I keep hitting Control S. True. So this is why you have to be careful, right? Because if you're running a sanitize filter and that sanitization removes all characters, or if the incoming parameter was blank to start with, the definition of returning null from filter input hasn't changed, right? It will still return null if it did not receive the incoming parameter. So, in this case, with a sanitize filter, you've got a whole different class of things that will trick the program into thinking the parameter wasn't sent when it was, if you're using weak equality comparison. Does that make sense? Sort of, hopefully. Incidentally, are you interested in why 0 is in this list? So PHP kind of derives a lot of its conventions from C programming, from the C programming language. It turns out that the way true and false are defined in C are as term rewrites for 0 and 1. So basically, if you have C code, right, that says, if, or while true, right, make an infinite loop, put a break statement in it somewhere, so it's not actually input infinite. As a pre-processing step, before this even goes to the C compiler, one of the things that C does is it performs symbol substitution in the preprocessor. And one of those substitutions is to replace true with 1. So basically the actual line is define true as 1, define false as 0. So while 1, that's the actual behavior. And the reason is that basically Boolean variables are too small to have their own segments in memory. Like, if you were to do this in binary code, a Boolean variable is 1 bit, right? It's a true or a false. It's a 1 or a 0, right? in computer architectural terms, the computer's architecture is really not built to handle one bit, right? It's not efficient to do so anymore. You know, back in the 1950s, when, you know, you had to build every circuit by hand out of like vacuum tubes and that sort of thing, it made a lot of sense to have like a 1-bit on or off circuit. You know, that's where Boolean derives from. But in a modern processor, there's no benefit to be gained for putting in a bunch of, like a whole lot of circuitry to handle specific binary signals, right? So, what do? They just use the standard word size of the CPU. You know, in our case, it's usually 64 bits. They just say, okay, the first one of those bits, that's the value. We'll ignore the rest, and that's a 1 or a 0. That's a 1 or a 0. How it actually works in terms of like the circuitry itself. 0 is false. All non-zero numbers are true. That's how it works in like the underlying circuitry. But, you know, it's convenient to work in true and false. That's why we have these defined as programming language constructs. But the concept of true and false is kind of fake. And the C programming language actually didn't have native support for a Boolean data type until 1999, which is like, you know, just to give some context, JavaScript itself was invented in, I think, the early 90s, and Java was late 80s, early 90s. So C didn't have a Boolean type while JavaScript was being invented, just for context. But anyway, so that's why 0 is in this group. Does that make sense? It actually does make sense if you understand it at that basic level. The problem is, without the presence of strict equality comparison, there's no way to tell the difference between those things in PHP. Does that make sense? Okay. So far, so good. So, as usual, here's a list of links to both the PHP documentation and W3 schools. Shall we do an example? Good. If everybody could please open up XAMPP, whichever you prefer. And while you're at it, just get the VS Code. You know something? It took me like half a semester of teaching PHP to realize that like this is the reason that VS Code produces a little elephant icon for PHP scripts, which seemed a little strange to me, but it's like intelligence. It's a pun, but it's not spelled like it's, it was intelligence. It's terrible. We don't really need it. Don't worry about it. It's just, I don't know. It took me too long. That's all. So, open up your htdocs folder. Oh, let's get our Apache server up and running first. now. htdocs. Make a new folder for this week. -02-13. Bing, bang, boom. Select folder. There we go. Yes, I trust myself. Thank you. And let's make ourselves a new PHP file. Validation.php. So, the last time we did this, I made an HTML form where we were sending stuff. At the present time, I think I'm just going to compose the incoming requests directly in the URL address bar, so that we don't have to worry about that. Let's just focus on the PHP for now, okay? So, of course, all PHP must be inside of a PHP tag. And let's start with the request. Let's put just a hello world in here for now, so that we know everything's working, and then we will formulate a request. So, the URL that we will find this thing, localhost, then the port number, in my case it's usually 1080 slash I named my folder the date, slash validation.php. And there is our hello world. Ta-da! So far so good? I'm going to compose the URLs in the notepad just so that, so that it can be read easily. So, review of get parameters. How do we attach get parameters to a URL? Does anybody remember the first character? It's a question mark, yes. Question mark. Now we send our parameters, or we specify our parameters as key value pairs with equal signs in between, separated by ampersands. So, just for the sake of interest, we could say x is equal to 1, and y is equal to potato, and z is equal to 6.9, 3, 5, and let me add w as a boolean. Or true. So, if we take this, copy it in, there we go, and take a look at our network tab. Refresh. In our validation request, you can see in the payload tab, there are all of our query parameters laid out for us nicely, like a delicious, delicious cheese platter at a Christmas dinner. Now, all we need to do is configure the PHP script to be able to receive them. First, though, let's get the let me show you again this little trick to be able to view exactly what the server is receiving. But what the server receives will be exactly this. But it's still useful to be able to, verify and validate that you are receiving what you think you're receiving. So, we can send the entire contents of the get superglobal so long as it has been JSON encoded. Once we've done that, you can see it sends back the contents of the array. Now, if there had been a script attack in this, we would just have fallen victim to it, right? Because we are taking inputs received from the client and then echoing it back to the client without checking it first. But this is not for the purposes of deployment, this is for the purposes of validation and bug checking. Make sense? So far, so good? So, let's first take X, just because it's always useful to start with integers. So, to validate X, first step is to use filter input. What is our incoming request type? It is get, yes. Input get. Next, what is the name of the parameter that we are seeking? It's either W, X, Y, or Z, right? So which one are we looking for? Well, here's a hint. What did I name the variable? So we're looking for? There you go. Now we get to choose what filter we like. VS Code is nice because it will autocomplete these. Filter, validate, integer. Now, X is in this situation we were talking about. Filter input is either returning null, false, or an integer. If X is equal to, see, I just about did it. I just about used double equals instead of triple equals. It's so easy to do, that's why I'm pressing you guys on it so much. So if X is null, parameter not received. Before E, except after C. So, in this case, perhaps we want to say something like parameter X was not received. Otherwise, X is false. Echo parameter X was not an integer. Now here's a trick, right? Here's a trick to keep your situation from getting too nested, right? If I slap an else case on here, X is valid. Here's a question. How many inputs are we validating? Right? We're taking 4 in this case, so we probably want 4. Right? Here, this portion of code is executed even if X wasn't valid and we sent the X is not valid response. The else branch is the only branch on which, it's the only part of the code where X is valid. X is guaranteed to be valid. So, that could be a problem because there we go. I need to charge my power bank. I don't know why I even use it. Like every single time I'm recording somewhere or where I have a computer, a lab computer adjacent where I can just mooch power off of it. But so it goes. What was I talking about? Exit codes. So you can test for this in a bash script, right? Very, very simple. It's like if return status was not equal to 0, then et cetera, right? You put some branch in for an if statement. But yeah, so you'd have these reference manuals where you'd have to look up your exit code and it would give you mysterious information about what that meant for that program. But the universal convention is return 0 means normal exit. Nothing went wrong. So for example, if I actually make touch a.txt, right? Echo hello, pipe to a.txt, at a.txt contains the word hello, right? Then copy a.txt to b.txt, inquire about the exit code, 0 exit code, because the operation succeeded, right? So, when you are writing PHP, that is what that argument means. That is, because this is a program that's running in a shell like that, right? You can think of a shell like, you can think of the server as having a shell like that. It's never really shown to you. You know, the server just kind of runs it in the background, and it's running all the commands that it wants to run. And it's dealing with it, it's using standard input, standard output, and exit codes, and all of that kind of stuff. This is basically how you send to the server whether or not things succeeded or failed, right, from your PHP script. From that point, you know, it's kind of like the server admin's job to figure out how they're going to deal with like non-zero exit status returning PHP scripts. But normally, here's the difference, right? That indicates an error on the server side, not an error on the client side, right? Because you might be saying to yourself, well, if I'm expecting a false, or if I'm expecting a parameter and I don't get a parameter, is that not an error? Is that not a problem? And the question is, whose problem? Right? Servers receive invalid requests all the time. Right? Again, never trust the client. Right? If the client sends an invalid request, that is generally considered to be the client's fault and the client's problem. and you get to decide what an invalid request is. This is where you are deciding what an invalid request is. But there are some errors that you run into which are not resolvable, which are the server's problem, not the client's problem. For example, failure to connect to the database. That's a server problem, not a client problem, right? In that case, you should tell the server something went wrong, and you should use a non-zero exit code. Does that make sense? Did you learn a little something about Bash as well? No? Oh, come on, I'm trying so hard. Oh man. The little demon sitting on my shoulder that wants me to teach you guys Bash just said, you know what you should really do? You should show them how to use command line parameters for Bash shells, Bash shell scripts as well, since you've shown them the question mark. It'll be easy enough to show them the numbers, which are also shortcuts for getting things in Bash. But you know, we have our own class that we're teaching, little demon on my shoulder. Not a mailer demon, unfortunately. Not as reliable. So, anyway. So that is, roughly speaking, how we might go about validating an input. So if X is valid, you know, for the time being, echo X. Then, if I, let's just get rid of this bit for encoding. If I send 1, I get 1. If I send 1,000, I get 1,000. If I send harpsichord, parameter x was not an integer, right? And if I fail to send x at all, parameter x was not received, which is both correct. Now, do you want me to prove to you that that issue I was showing you with the double equals, or are you satisfied that that's true? You want to see it? Okay, let's see it. So let's assume, just for the sake of argument, that I was an inexperienced PHP programmer who didn't understand the difference between double and triple equals, and I wrote my code like this. If I send the request like this, with no x parameter, parameter x was not received. If I slap x on the end, but it's not an integer, so, yeah. You can see I'm getting the wrong error message. I expect to be getting parameter x was not an integer, but what I am actually getting is parameter x was not received, which is not true. It was received. It was sent and it was received. The problem is the return value of x is false in this case, which equates to the same thing as null, which means that the first branch is executed. We hit the exit statement and we execute no further. Does that make sense? So, all I have to do is put these back to triple equals, and we get the correct output, which is that it's not an integer. Another nasty little side effect, what if we send 0 under weak equality? 0 also turns out parameter x was not received. Now, 0 is kind of a tricky number because it's often like very valid, you know? It's kind of ridiculous to send an integer and exclude 0. So if you don't use strong equality comparison here, you are even like dipping into and cutting off the range of valid integers that the thing will receive, which is a problem because, again, 0 is often a very useful number to send, right? So, moral of the story is use strict equality comparison for these sorts of operations and whenever possible. Whenever, you know, you really should default to it for most things, unless you're like, I do want to see if this string contains a numeric integer. Unless you're like explicitly needing the type conversion, you should default to strict equality. It'll behave much more similarly to the C# that you guys are used to working with. Make sense? All good? Have I beaten the dead horse long enough? Okay. I know I'm beating a dead horse, but it truly is like a very important point. So, I'm going to sneeze. Possibly. Perhaps not. So, let's take the other inputs while we're at it. Let's do Z. What is Z? Yep, what's the data type? It will be a float. There we go. Very good. There we go. I'm performing multiplication on x and z now because they're both numeric. We can see that everything works out. If we wish to take y, which is a string, filter, sanitize, see how the sanitized string is crossed out, but still there? Would you like to know why? So basically, and this is a relatively recent thing, sanitized string is being deprecated. That's another piece of programmer's lingo. So deprecation means you express disapproval of, disparage, or belittle, chiefly of a software feature, be usable but regarded as obsolete and best avoided, typically due to having been superseded. This feature is deprecated and will be removed in later versions. So basically it's just there for compatibility at the moment. Sanitized string is the character removal algorithm. Sanitized special characters is the character replacement algorithm. Sanitized special characters is the new version, which is superseding sanitized string. sanitized string will probably be removed in later versions, so you should just get used to using sanitized special characters. Make sense? Sanitize special characters. There we go. Oh, I made a mistake. Should be Z. That should be Z as well. So, because this is a sanitized operation, we don't have to worry about the result of y being false because it's failed a validation filter. This isn't a validation filter, this is a sanitization filter. Instead, we can test to see if it's the empty string, in which case we would say, oh, Z, Y, Y. An empty string means that the thing wasn't set. Save. Like the parameter was sent, but it was blank. Here we go. So if I take potato out, oh man. If I take potato out, in theory,
Where you have the Y filter input as Z.
that would do it. Let's try her again. There we go. Thank you. Every time. But like, I think we've all done enough programming at this point that like, that's the game, you know? Programmers hate that process because it's error prone. So, let's concatenate. There we go. Add that to our output. Y is a bowling ball. There we go. Now, I would like to draw your attention to one little syntactic trick that I used here. Notice how I've included curly braces around the variable name. The purpose of doing that was so that I could put an S on the end to make it a plural word, right? In PHP, if I didn't have those, you can see how it's highlighting things. It would expect the variable name to be ys. So if you're using the string splicing method like this, it expects a space character after the variable name to designate the end of the variable name. There you go. No undefined variable ys. If I put the space in there, it works, but it has the space, right? So, if you really want things to be tight and look nice and lovely, that's how you do it. Further, if you're using the squiggly brace notation, you can do more advanced operations like array access in here as well. So, for example, if I wanted to blow out all of my lovely validation and just go directly to get parameter again, concatenation operator. So in PHP, it doesn't work the same way that it works in C# or Python or Java. Plus does not mean concatenation, it only means arithmetic addition. Yeah. So plus, the plus sign only means math. Period means concatenate. So if you're joining two strings together, that's how you do it. Further, the concatenate operator will type convert anything that's not a string into a string. So here I've got an integer and a double. Those multiply together to produce a double. The dot operator forces conversion of that to a string and then concatenates it to the rest of the string. Does that make sense? Cool. Yeah. Do you want me to do W? Or, yeah, let's do W. We'll do W and then we'll do the break. Yep? So, for W, W. It's a bit tricky. Filter, validate. Here's the issue, right? The set of failure conditions from a validate filter include false. The set of possible valid, like the range of valid inputs, also includes false. So we have overlap between our error status codes and correct inputs. So we have to think about that. In this case, it's useful to let's consult the documentation. So, filter validate Boolean, and then we can specify an optional flag. Filter null on failure. So, these flags that you can provide go as additional arguments, right? In this case, null becomes, it shifts that negative outcome from false onto the null value instead, which is not the default behavior for filter input, but it does, fortunately, reduce, it means that if we receive a false value, we can tell the difference between that and receiving an invalid value, which is good. Even although we now cannot tell the difference between receiving an invalid input and receiving no input. So, trade-offs. But, kind of interesting, the things that will test as Booleans, 1, true, on, and yes, false, 0, false, off, and no, and also the empty string. So, often you would just generalize the error message to a problem occurred. Get rid of that. If W is equal to true, else there we go. So if W is true, it will output, X stacks of Y, otherwise X heaps of Y. Let's test her out. Stacks of bowling balls because we sent true. Let's send false. We get heaps of bowling balls. If W is gross, a problem occurred. If W is not sent, not interested. You have to put in a secondary check. If W is set, do that before the filter input. If not is set, get W echo parameter W was not received. Otherwise, parameter W is not. Parameter was not received. And W equals off. We get heaps of bowling balls. So, in this case, filtered input was not doing all of the input filtering that we needed. Setting the optional flag here meant that null is now failing the validation filter, but failing that, it was basically making W an uninitialized variable afterwards, which means it fails this condition because it's got an implicit undefined value or something. So that's why it's useful to be able to know how to do that by hand, because in some situations you'll have to, right? Depending on what it is that you're taking in. So over-reliance on this is also not good. You should still know how things are working, because every once in a while one of these fancy methods will fail and you'll have to do something else. Does this make sense? So far, so good? Okay. In that case, I think we shall have our 20-minute break in our 4-hour class. Any questions before we hit the break? Okay. Well, class shall resume in 20 minutes. So, moving swiftly on. Let's talk Ajax. I've been name dropping it for like a long time. There we go. Ajax. So. Before you all jump down my throat, we are not talking about Ajax, hero of the Trojan War, who fought on the side of the Greeks against the Trojans. That's not the Ajax we're talking about. Ajax stands for Asynchronous JavaScript and XML. But really, we don't send that much XML these days. It's mostly JavaScript object notation. So the idea is that Ajax allows a client to make HTTP requests without causing the page to reload, without causing a refresh. It's an asynchronous transaction. So this is what you do, right? This is what you set up. Oh, I should mention, this is now back in JavaScript land. So we are now talking about JavaScript again. Ajax, you code Ajax in JavaScript only. And this is the other half of the communication, right? Before the break, we did the PHP, the server side of the communication. Now we're talking about the client side of the communication, so this is necessarily going to be in JavaScript. So, pardon me. Ajax should be thought of in the following manner. Imagine that the client and the server are playing catch with a ball, right? Ajax is the process by which the client throws the ball to the server and sets up its catching mitt, right? The throwing of the ball is the encoding of the URL and any of the parameters that are being sent. Setting up the mitt is deciding which JavaScript function will execute when the server returns its response. So, JavaScript code is responsible for programmatically making the request and managing the response. So, remember the difference between a client and a server. Servers cannot push information to clients. It's not possible. They don't know who the clients are, where they are. They can't just search the internet for the client, right? All information coming out of a server is in response to requests by clients. So, managing the origin of the request and how that request is handled ultimately falls to the client, ultimately falls to JavaScript. So, I think I'm going to do this one on the board. So, traditional interface. We have client, we have server. The client always originates requests. That request can take the form of, so when you're talking about regular HTTP transactions, you're basically talking about page requests. Right? You're either logging into a particular URL or you're clicking a link of some kind, but the expected thing that happens is that the page, you get a new web page as a result, right? The server does its thing and then responds with an HTML page. Additional resources might be requested, you know, CSS, JS files, image files, other resources, right? But fundamentally, the thing that this server is sending back is always a file, right? In normal transactions, everything that's being sent back is a file. Make sense? So far so good? Contrast this to an AJAX request.
Sorry, Dr. Moon, what are we calling the initial case here? Normal?
Yeah.
Perfect, okay.
Yeah. Like, it would be incorrect to call this one HTTPS and this one AJAX, because AJAX is still using the same packet protocol. It's still using HTTPS. It's just using it for a different purpose. Normal HTTPS resource request. So, under AJAX, first of all, it's necessary that a page request happens first, right? Basically, and let's put it this way. All of this stuff happens, and then you can have AJAX, right? Because AJAX is carried in JavaScript, the JavaScript has to be loaded by a web page before it can be executed, right? So you don't really get AJAX requests without having first loaded all of the remote resources you need, right? So AJAX, another way of thinking about it, AJAX requests occur while the website is running. This sets up the website, this occurs while the website is running. So what happens is, the client makes an AJAX request in order to send parameters. Typically to send parameters, although you can also send other data, let's just talk about parameters for now. Like, you can technically send like image files as well. You know when you update your profile picture for like an avatar on something, right? That is also sent, like that is sent via the same mechanism, but it's a different type of request. So we send stuff here, the server processes it, the response is not normally a file, but a string. And you might be saying to yourself, well, if the file is text encoded, it's a string anyways. But it's useful to have a distinction, right? The information that we are sending from the server is often, well, it's not necessarily something on the file system. It's not necessarily like, you know, q.png or, you know, 3.css or whatever, right? It can be the state of variables in the PHP program. It can be information which has been collected from a database. We're not just requesting a remote resource. We are asking the information to be generated for us, right? So, the string that's sent back will either be plain text or something like JSON, right? JSON most of the time. Even if you're sending, even if all you're sending is a plain text message, that will often be wrapped in JSON because it makes it easier on the JavaScript side. Does this make sense so far? So this information, once retrieved from the server, it is then integrated into the website using JavaScript rather than reloading the page. So, you know how in JavaScript we were able to dump a hello world message into a paragraph or something like that? Same process, except the data is originating from the server rather than from our JavaScript file. Does that make sense? Hopefully. Well, let's continue. So, what is Ajax's purpose? Ajax is what allows us to make web applications that feel more like the desktop applications that we all know and love. In fact, this technology is so good that desktop applications are kind of gradually falling out of favor. A lot of them these days are, a lot of what you think is a desktop application is actually under the hood just a single purpose browser that's loading a web page and using the web interface. So, imagine if you had an app like Google Maps. Every time you needed to pull more map data out of the server, you had to refresh the page. It wouldn't work, right? Same thing with like Google Docs. Imagine every time you checked to see if somebody else wrote anything while you were writing something, it refreshed the page. It would be unusable, right? So, it may surprise you to learn that if you have Google Maps, it has not loaded the entire map of the world into our browser right here, right now. It would have taken too long, right? As you scroll out, you can see the chunks popping in, right? The chunks that pop in, that's that information being loaded via AJAX requests. So, good. AJAX requires front-end code to make requests and some kind of back-end resource to be returned as a response. So, AJAX requests originate in the client in JavaScript, but there must be something on the server which services the request. Again, this is different from our normal everyday page access using HTTPS. If all we're doing is like things to the level of assignments 1 and 2 for you guys, just do a web page, just do some client-side code, there's no need for a PHP script to service these requests. All that you are requesting is files off of the server. The server knows perfectly well how to send you files. It doesn't require a PHP script to do so, right? Make sense? So, it's only once we start introducing sending things like parameters and other information via AJAX requests that the server has to be configured differently to be able to service those requests. That's the purpose of PHP. So, it is possible to use AJAX without using jQuery or other front-end libraries like Fetch. A special object built into JavaScript assists in making AJAX requests, standardized during an earlier web era. However, it's far easier to use a framework and still safer in terms of cross-compatibility across browsers. So we're going to be using the jQuery approach here. jQuery.get makes an AJAX GET request. Now remember that this is an HTTP request in a general sense. So all of your method types are still available here, right? We can make GET requests, we can make POST requests, we can make delete and put requests, all of these types of things. And given the naming convention here, you can probably imagine what the form of the other requests will be. So, here is the syntax. We have $.get initiates a GET request, open round braces. We then provide a JavaScript object containing the options and parameters and all of the rest of it that we wish to send. We provide a function, number one, with the URL to request. Now, fortunately, this does not have to be the full URL. Similarly to requesting data, or similarly to including a script file, the file name can be a relative file name, which is good. We need to send an array representing our query string, although that's not it's not strictly necessary. It is possible to call a PHP script without sending in any parameters, in which case data is optional. We need a success callback function that will handle the response. So success here is a function, a JavaScript function, which will handle the response that's sent back by the server. The callback function is provided with the response as an argument, and additionally, we specify the data type to expect in the response, for example, JSON, which will dictate how to interpret the format of the callback function parameter. So data type is like, what am I expecting to get back? Am I expecting to get plain text? Am I expecting to get JSON? Am I expecting to get a blob? You know, you guys, have you heard of blobs? in this context. Blobs are basically big gooey hunks of binary data. So if you're receiving an image via this method, you are receiving a blob. That's what the data type is called. Make sense? So, to return to the baseball analogy, URL is which player you are pitching to. Data, contents of the ball. Success, which mitt you are using to catch the ball when it gets thrown back to you. Data type, well, more details about the mitt, I suppose. What type of ball is the mitt expecting to catch? So, for example, get myscript.php specifies the name of the PHP file that we intend to get. The next line is the data. So key 1, value 1, key 2, value 2. Function taking data simply reflects it into an alert box. So whatever is sent back by the server gets put into an alert box. This would request myscript.php with a get request, provide it with the query string, ta-da, and the callback function, which would launch an alert pop-up box to display the text as data. Shall we try it out? So, let's make a new file, index.html. There we go. Ta-da! For the time being, let's just call this Ajax and be done with it. Now, since we are using the jQuery, what do we have to do?
I have a question with this document.
Oh yeah, sorry.
For the jQuery,
Yeah.
that statement to bring in the jQuery, that has to go at the end of the HTML document, not at the top, is that correct?
It should go at the beginning, in the head. Let's do the whole process. So, download jQuery 3.7.1. You want to do the download version or the CDN version?
CDN is probably good.
Okay. There we go.
I was under the impression that the HTML document had to be loaded before jQuery comes into play.
So, no. So the HTML document must be loaded before you make modifications to it, right? But the jQuery library doesn't make any modifications to the HTML. All it does is make certain language constructs available in JavaScript. So it must be loaded before your JavaScript is loaded. But it must, it it has little to no relationship to how your, like your paragraphs and all that get loaded.
So it should be placed in the head.
Yes.
Got it. Sorry about that.
No, of course, please. It's very important. So, there we go. If you click on minified, and the reason you want minified is because it takes up less space and less bandwidth. You always want less bandwidth whenever possible. Copy that in. There you go. We now have jQuery. Now we can add our script. Script source equals some Ajax dot JS. We can click to create a file, and now we have some Ajax. Boom. With me so far? Good. Now, let's make a simple little PHP script. All it does is echo the parameters that it's given. Simple.php. Echo JSON encode get. You know, this little trick we've used a couple of times now. Save. And save. So left, right. There we go. So now we want to write an Ajax request in our JavaScript that will communicate with our PHP script. So, .get. The next thing we provide is the URL, a relative URL, which in this case just means the file name. Simple.php. Next, we specify the parameters we wish to send the data. So A gets 1, B gets 2, C gets 3. So just a stylistic note. There's a reason that people will, in JavaScript, do stuff like this and like separate lines on commas, because that way it's not just one big long line that's completely unworkable. And finally, we need to specify a success function. Let's call it callback. Now, in the slide example, we're using an anonymous function for this purpose. But I think it would be good to just pull it out, give it a name, do it in like a less compact form, just to demonstrate that this does actually interact with all of the JavaScript that you guys have been doing so far. So, function callback, taking the data, or console.log data. There we go. make sense? Sort of, hopefully. So, let's see if this actually works. Let's take a look at our network. So things aren't working by default, which is not unexpected in Ajax. At this point, it becomes very, very highly necessary to know how to look at the network packets and see what the heck is going on and what might be going wrong. So go to your network tab, resend the request, and we can see why is, yeah, okay, that's good. So we're loading HTML, we're loading jQuery, we're loading some Ajax, and you can see that our simple.php has been sent. So sending the Ajax request has worked. It even got a 300 status return, or a 200 return, which means it was successful. Response. So, oh, wait, I'm looking in the wrong place. There we go. Pardon me. I thought, for some reason, I forgot what I did, and I thought we were going to get an alert box, but no. We asked for it to be printed to console, and there it is. But let's go through the network traffic anyways, because that might be instructive. So, our simple.php GET request, right? The payload, A is 1, B is 2, C is 3, just as we gave in the JavaScript, right? This is a preview of the response string, which we received from the PHP script. It is JSON encoded, right? But remember, in the PHP script, we did use JSON encode right here. So, whenever you use JSON encode and then send the information that way, you have transmitted JSON. On the client side, it will need to be pulled out and dissected as JSON.
On the server side.
On the client side. The server is sending it. Right? This is the response we're talking about, right? This is the request. This services the request. This services the response to the initial request. So it's like a ping pong ball. It's like 1, 2, 3. Does that make sense?
If you, in that Ajax file, if you reverse those two and the function below the GET request, is that going to work as well?
Normally I like to have functions defined before they're used, but let's see. JavaScript's kind of a funny language. Maybe it just keeps a place for it and waits for it to be defined later. Let's take a look. Oh, everything works. So yeah, that works too. That's like an old, you can tell I'm a C programmer because in C, this would cause a syntax error because callback hasn't been defined yet. So that's why I defined it above the Ajax request. So, but JavaScript, everything is so loose that you can do stuff that doesn't even make sense, like use functions before you've defined them. But you're not really using the function here. You're telling it use this in the future. So, it's a pointer to a function, not a function. It's not a function call. But yeah. So 1, 2, 3. Make sense?
So it's being sent without being encoded. When it gets to the server, it's encoded by JSON, and that's sent back.
In a sense. So these are get parameters, right? Get parameters are sent in the header and not in the payload, right? So when I send A, B, and C, that's being sent in the header, right? It's not encrypted, and it's just being sent as get parameters. This does end up in the payload of the response packet. So when we call the callback function, it's receiving the payload. Does that make sense?
Yep.
Cool. This is about as simple an interaction. This is as simple as I can make this interaction in as few lines of code. So I hope this is clear. The only thing simpler than this would be to be like sending no parameters and like a hello world back from the server, which I can do if you want to see it. You want to see that? A hello world from the server? Yeah? Okay. Very simple. Echo hello client. Client sends no parameters. Hello client. Back code again. Okay. This is actually as simple as this code can possibly be, without, while still having some data being sent. So I removed the get parameters I'm sending. Just invoke the PHP script. It sends hello back. Put that in the console. That's it. Question?
What's happening in the HTML file?
Precious little. I just set the title. However, this is just logging to console, right? In theory, these should be used to set up some kind of interaction which is visible to the end user. So, we can very quickly set up a paragraph tag with Ajax output. Pop that over here. Instead of, or perhaps in addition to, logging to console, we can also, are you hearing weird sounds? Huh. Okay. Ajax output dot, oh my goodness, am I forgetting? I think I need to look it up. Modules. Where is it? text is then data. So we're taking the ID Ajax output, extracting its object reference, using the text action to set the text to the data that was returned through the call. Save that. Go to our website. Hello, client. It's in a paragraph now. Make sense? So that's text data, right? It gets more complicated, but for now, let's return to the slides. We have probably 2 more and then references. Yes, yes, yes. So, in addition, so we've talked about text. We know how to get text now. Text is good, text is fine. JSON is more useful. If you specify JSON as the final parameter of the GET request, we are telling the AJAX request to receive the incoming data as a JSON. We are parsing it as JSON, which means we are receiving a JavaScript object, not a chunk of text. This can be more useful. The callback function would interpret the response as JSON data, allowing us to access it in the data.key style. So, we'll do an example of that, but first let's talk about this. .post is equivalent to .get, but sends a post request instead. You know, as you probably, it's not too bad, it's not that big a leap, right? Query string provided would be received as post in the post superglobal in PHP. A PHP script can use a query string to dynamically decide what to do and what to return. For example, access a database or return results. PHP can return JSON data using the method JSON encode, as we've seen several times already. So let's do an example where we are sending some JSON back from the server. So this, the PHP is going to get a little bit more complicated. So this is what I want to do, all right? I want to send back the phrase, hello world, but I also want to send back a randomized color. Maybe randomize the color between 3 different options. The PHP script decides what color that text should be on the client. Okay? Sound good? Are there any questions? No? So, first, let's set up a response. The text of the message will be hello world. Oh yeah, it uses square braces, doesn't it? This is the problem with being multilingual in programming languages. So, response text is hello world. Echo JSON encode response. Let's take a look at what that looks like here. First, let's just run the code as is and see what happens. You can see that we get the JSON as a JSON string. That's fine, that's what you get when you interpret a JSON as text. But we want to do something a little bit more useful with it. We wish to interpret it as JSON. Now, what happens? We get object. Now, you probably haven't gotten this far in JavaScript yet, but if you have some random object and you try to print it as a string, that's what happens. So we're no longer working with pure text. How about data.text though? Because it's been JSON encoded and decoded on the other side, we can now access the parameters and the fields of that JSON response using dot syntax. But the object itself is an object now in JavaScript. You can't just print it directly. Although you could, like, printing an object console is actually very useful because it allows you to like go through all of the values in it. But it's just not useful to print it out into your web page. Is this making sense so far? Not too bad? Okay, good, because I tell you, with my JavaScript class, this was considerably, they had a tough time with it. But it really makes more sense if you have the PHP piece in there, and they didn't. So, because they do PHP in third semester, so, and JavaScript second semester. But anyway, so, now, let's have some fun. So let's say choice is equal to math dot random. Do I have math dot random? Let me just check to see what they call math dot random in PHP. Random int. Okay. Cool. Random int between 1 and 3. Switch choice case 1, case 2, case 3, break, break, break. You're gonna auto format for me? No? Okay. Oh, by the way, it's a little trick. If you highlight a whole bunch and you press tab, it tabs all of it over. But if you want to reduce tabbing, shift tab will reduce the tabbing back again. So that's just a handy little trick for you. Quality of life thing. I do, yeah. Thank you. So, in this case, response at color, Canadian spelling, is equal to red I load that PHP script, I'm getting a different, well, you know, I'm changing between those three colors. So the question then is, how do we hook that up here? Ah, yes. I remember now. I'm still thinking in vanilla JavaScript terms. Set CSS property color to data.color. Now, there we go. Cool, right? So here's the thing about an AJAX request though. These things are JavaScript, and you can do, like, at the moment, we're kind of doing something a little bit silly with this because we're just sending an AJAX request from a JavaScript file once at the beginning. That's not really what JavaScript is good at, right? There's no point to doing this. I could just set the color in JavaScript randomly. Why am I doing this, right? It all comes together once you integrate the event system in JavaScript. So, for example, perhaps we have a button. In HTML, button, send request, and button. On click equals, and then we just have to encapsulate that GET request in a function. We'll call it GET request, GET rec. So function GET rec. There we go. There we go. Just throw that in a function. Specify that function over here. And now we have a button that, if everything works correctly, oh, yeah, no, I think you have to have those. Let's see here. There, I must not have saved. Send request, click, 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 click. So you can see, we can now communicate with the server as many times as we like using a button. We can also set up a timeout, or a, not a timeout, an interval. Set interval, call GET request every 2 seconds. Refresh. every 2 seconds, I'm sending that AJAX request, getting the response back, and the color of the statement might alter depending on what the value being sent back is. Cool, right? So, one cool thing which is important to note about JSON, like one big advantage to it. If you're working with text, then anytime the form of the response changes, you have to completely redo the client-side code to respond to that change in output. But here, I can add as many additional things to the JSON as I want. The code that uses text and color does not have to be touched or modified or altered, so long as it's still, what I want it to do. So that's another advantage of using JSON. Any questions? Cool. So, let me consider a more complicated example. How about ooh, okay, I've got it. Let's do a simple little website. Two text boxes, a submit button, and it gives the output of the two numbers added together. And it does all of this by AJAX, so you can hit that submit button as many times as you want, and it just appears in the page. We could also do that as an alert page. Does that make sense? Shall we do that? Okay, sounds good. So, let's build off of our existing work for this. Let's make a form, or no, we don't need to put it in a form. Input type is equal to text. ID is equal to value 1. We also want value 2. Go. So, let me show you what I did. Input type equals text. 50 pixels just to make it narrow enough to be seen. Value 1, value 2, and equals, here's a span for the Ajax output. Click the button to get your output. Very good, very good, very good. In our code here, we need to send those values to the PHP script using Ajax. So, recall that that will be our second parameter. We'll send it as x and y. Now we just need to grab those values out of the web page. Their IDs are value 1 and value 2. And val. There we go. We are now sending the values collected from value 1 and value 2 in our Ajax request. Point now is to do something with that in our PHP script. Text, I believe, in this case, should become the values of those incoming get parameters. So, x and y are the variables we want, and of course, we're going to do things properly. Here's the thing. Just because it's originating in an Ajax request does not mean that you are receiving correct data. A hacker can send an Ajax request just as easily as a hacker can modify a URL. So, we still can't trust it, even though it's coming from an Ajax request. We must filter properly. Filter input from input underscore get. The parameter we're looking for is called x, and we're using filter validate int copy paste replace x for y. Now, x plus y, concatenate empty string, which is my little shorthand for please convert this to a string pretty please. Technically speaking, it will, I think in this case it would actually transfer it through fine, but we'll just do that. Alright, there we go. Save. Now, we consider our JavaScript again. Text, CSS should all work. Let's take a look. Ajax. You can see we've got 0. There. The reason we had 0 is because the set interval was still wrong. So, 2 plus 2, calculate 4. And we still get our colors. There you go. Neat, right? And here's a fun thing too. We're doing this with on-click for the button, but we also don't have to alternatively, we could specify these as on change. Get request. That way, as soon as the text box loses context, it just sends the request automatically. Making this button completely unnecessary because it's always only repeating an operation, unless you like the pretty colors. Any questions?
There's a lot of back and forth.
Well, yeah, that's kind of the subject of the week, you know. Like, we have 25 minutes remaining in class, so if anybody has any questions about this, anything they'd like me to go over again, anything to clarify, now would be a good time.
I have a question about the assignment.
You have a question about the assignment? Okay. Have you been working on the assignment? Been paying attention to that? It's all good. Ah, yes. So, the way that radio boxes work is that they all have to have the same name, I think, if I recall that correctly. So if I change these to one, two, three, save, refresh. Yeah, there you go. So it knows to group them because they have the same name. Because they had different names, that's why it wasn't working.
And then how do I fix the spacing?
Which spacing? Oh, like you want to reduce the spacing?
Yeah.
Well, you can always just introduce a bigger gap here. I know you're not supposed to use breaks, but it's okay. This is JavaScript. If you'll notice, a lot of the time that gap is actually left in on web forms.
Yeah.
Any other questions? The problem that I kind of have with this so far is that, like, despite everything, we're still kind of not really doing anything more fancy than, like, we're not doing anything we couldn't have done in vanilla JavaScript, right? You can certainly do that without having to send requests back to the server, right? So the question is, why would we, you know, what would make this useful from a server's perspective? So the purpose of the server is shared information and shared resources, right? So, for example, let's do a site counter, right? something that will track the number of times a website has been viewed. Now, this will require a little bit of PHP code that we haven't covered yet, but that's okay. We'll muscle through. So let's make another thing down here. You are the span visitor to this site. Right? ID get visitor number or visits. There we go. Right? So you are the X number of visitor to the site. In order to so basically, we need the server to keep track of how many times the site has been visited. To do this, we need to invoke a PHP script every time the page is loaded. So in this case, you actually do just want a GET request at the top, right? So GET. Oh. Let's call this visit tracker.php. Sends no parameters, and function will be visitor callback. Function, no need to JSON encode this. Let's keep it simple. Right? Now we need the PHP script. Visit tracker. So, when PHP scripts run, they do not share information between different sessions. If visit tracker is called 50 times by 50 different people, there's no way in the PHP code itself to transfer information between these different calls to the same script. So what we need to use is a file on the file system. So if you go into, so what we need is a data file, right? Visits.data. There we go. Contains 0. Let's initialize it to 0. If you wanted to be extra fancy about this script, you would have it detect whether the file exists, and if it doesn't, create it and initialize it to 0. But for now, let's just have the file as initialized. Visits variable is equal to file get contents. String file name is what was it? Visits.data. My tooltip is blocking the name. There we go. Visits.data. Secondary options are not useful, I think. Echo visits. And let's just put like a number in there that's unique so that we know that we're getting our data back. There we go. So now it should tell us that we have 7 visitors to the site. Oof. Let's see. Oh, I didn't write the callback function. Nah, there we go. All right. Function visitor callback. Taking data. All we want to do is output that data. Very simple. And let's log it while we're at it. So we're getting 7. There's something wrong here. It's not hooking up to my span for some reason. Defaulting to vanilla. If you know how to do something several ways, it can be useful to try it a different way. The inner HTML equals data. Oh, wait, I think I know why. I think I know what the problem is. I'm receiving textual data, not a JSON object. So I was accessing a field that doesn't exist. That probably was the reason. That was probably the problem. Yeah, there you go. Good. So the next part is that we want to modify the contents of the file to increase it by 1 each time. So visits plus plus, and then file puts contents, file name is visits dot data. This, by the way, is the quick and dirty way of doing file interaction. There's a lot more to it, but this is like the basic version. And then visits. And let's reset this to 0. Now, refresh. Oh, bar 0. Did I forget a semicolon or something? Yes, I did. There we go. So, you are the first visitor, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, etc., etc., etc. Every time we reload the page. Now, what's impressive about this, if I had this on CS Unix, all of y'all would contribute to this total. It's not individual per person. It literally is every single time that PHP script is run, it increases the site count. It increases the number in that file. So 30, right? It's actually modifying the contents of the file. So, is that cool? Neat? Kind of fun? If you're not having fun, what's the point? All right, I think that we'll call that for today then, as class is now over. Thank you very much for your time and attention, folks, and see you on Friday.